Hello everybody. We are going to discuss the principal values. Find the principal values of the following questions. These few questions I am taking and we will discuss. Then how can we find out the principal values of these questions? First I am taking, that is your sine inverse minus 1 by 2. We want to know the principal value of this one. So principal value of sine inverse x is minus pi by 2 to plus pi by 2. This is already we know that. The principal value branch may, in case of the sine inverse, this is minus pi by 2 plus pi by 2. So how can you find out? So here you can assume that x is equal to sine inverse minus 1 by 2. So this is x is equal to, you can write down, and sine x is equal to minus 1 by 2. This x is equal to sine inverse for minus 1 by 2, you can write down this one. And this is minus the value of sine 1 by 2, that is pi by 6. So this can be written as sine x is equal to sine minus pi by 6. So therefore x is equal to, you are getting what? Minus pi by 6, and this minus pi by 6 is already going to belong to this interval. That is the principal value of the sine inverse x is minus pi by 2 to plus pi by 2. So we should be very, very careful about the principal value of branch of any one of the trigonometric function. Whether this value which you are getting here is lying between the given principal values or not. So therefore the principal value of sine inverse minus 1 by 2 is minus pi by 6, and this is your answer. Have a look. Okay, now next question is find the principal value of cos inverse minus 1 by 2. So look at here. This is already, we know that the principal value branch of cos inverse is 0 to pi in closed interval. So this is the very, very important point here. That's why I have written here only, because this cos inverse, sec inverse and cot inverse, they are in one group from 0 to pi, and these three are in one group from minus pi by 2 plus pi by 2. So that is the principal value branch you must know, then only you can find out the principal values of this one. So here is also same, let x is equal to cos inverse minus 1 by 2. So this can be written as cos x is equal to minus 1 by 2. So this is minus cos, the value of this one is pi by 3. This is the value of the cos, pi by 3 is there. Yes. Now here is the important point is here. This is exactly, if you are going to talk about the x, that will be equal to cos minus pi by 3. But this minus pi by 3 which you will get from here only is not going to belong this one, 0 to pi. Here is 0 to 180 you can say, but here you will get minus 60 is there. So it means you are supposed to change this one is there. So here, see, cos, this one remain the negative. So where the cos is negative is here only. So we are supposed to take on this one, on this horizontal line, that pi minus. So this can be written as cos x is equal to cos pi minus pi by 3. Because this is already, you know, that cos pi minus theta is equal to minus cos theta. Because on this horizontal line, all the trigonometric ratios remain same. This is already rho, that is already read in the 11th standard. On this vertical line, the sign change in cos and sine, like, or tan and cot is there only. So we know this is. So this can be written as cos x is equal to cos pi minus pi by 3 means 2 pi by So therefore x is equal to 2 pi by 3, and this is pi by 3 is going to belongs to, this is 0 to pi. See now, this is the value here is 2 into 180, 60 into 1, 2 means 120, and 120 is already lying in this one is there only. Or as usual already we know that these values are always from 0 to pi is there only. So the principal value, the required principal value is 2 pi by 3. This is your answer. Have a look. Yes. The next question is, we are taking sec inverse 2 over root 3. Sec inverse, this is C part. Sec inverse 2 over root 3. This is. And this is already we know that the principal value of the sec is inverse is 0 to pi except pi by 2. Sec 0 to pi, but it is does not exist in pi by 2. So same method is there. You can assume let x is equal to sec inverse 2 over root 3. So here you can write down sec x is equal to 2 over root 3. So this is the value of sec x is equal to, this is the value of sec 2 over root 3 means pi by 6. Pi by sec 30 degree is equal to 2 over root 3. So therefore from here you can say x is equal to what? Pi by 6. And this pi by 6 is belongs to this one, 0 to pi minus except this one. Means this is your 60 degree and this is already lying in this one. So therefore the required principal value is pi by 6, which is your answer. Have a look. Okay, next question is cot inverse root 3. So the principal values is already we know that cot inverse is 0 to pi in open interval. So here is same way, let x is equal to cot inverse root 3. So this can be written as cot x is equal to root 3. And the value of cot in is root 3 is cot pi by 6, because cot 30 is equal to this one is there. So therefore you can say x is equal to what? Pi by 6, and this pi by 6 is belongs to this principal value branch of this cot inverse. So therefore the required principal value is pi by 6. This is your answer. Yes, now look at this question is there. Find the principal value of this tan inverse in bracket 2 cos 2 sin inverse 1 over 2. And this is already we know that the principal value branch of tan inverse is minus pi by 2 plus pi by 2 in open interval, not included. And value of sin inverse is minus pi by 2 plus pi by 2 in closed interval. This is already we know that. So keep in mind these 2 points. So now here, this is tan inverse 2 cos 2 sin inverse 1 by 2. This is there. So first of all we are going to solve this one is there. So either you can separately you can solve this one. Just you can take x is equal to sin inverse 1 by 2. So sin x is equal to, you can assume that is equal to 1 by 2, and this is the value of sin pi by 6. So x is equal to what? Pi by 6, and this pi by 6 is already belongs to minus pi by 2 to plus pi by 2. So in place of this one you can write down, this is your tan inverse 2 cos. And in place of this sin inverse 1 by 2, what we can write down? We can write down this pi by 6. So this is 2 into pi by 6. This is tan inverse 2 cos. This is 2 3 ja. So this is pi by 3. And this is equal to tan inverse 2 into the value of cos 60. That is also 1 by 2. 2 cancel. So finally we are getting tan inverse 1. Again here was same thing. Let y is equal to tan inverse 1. So tan y is equal to 1, and this is the value of tan pi by 4. And this pi by 4 is already belong in this interval minus pi by 2 to plus pi by 2. So this can be written as, this is equal to that pi by 4, and this pi by 4 is already belongs minus pi by 2 to plus pi by 2. So therefore the required principal value is pi by 4, and this is your answer. Have a look. So the last question is cos inverse into this cos 14 pi by 3. See, already we know the principal value branch of the cos inverse is 0 to pi in closed interval, means they both are included. So if we talk about this one, this cos inverse, cos 14 over pi over 3. So 14 pi over 3 does not belong to this 0 to pi, because 0 to pi means 0 to 180 is there, but this value is more than this one, is toward this one, because already we know that the cos inverse x is from 0 to pi is there only. It means this is does not belong to. It means we are supposed to change. So this can be written as cos inverse. This can be written as cos 4 pi plus 2 pi by 3. See, you can write down this one is there. See how can you write down this one? Look at here now. This is 4 pi means here to here we are going. This is one round is there. 360. 4 into 180. This is 720. So 360 is here. Then again we are going to complete this one. This. So you are here. So plus we are doing. Plus we are doing. It means we are ultimately we are coming in the first quadrant. On here is there. On this line, cos will remain the cos and sine will remain the sine. Because but this can be written as in this way. So this cos 4 pi plus cos 2 pi by 3 is equal to cos inverse cos 2 pi by 3. Here is already you know that on this horizontal line, already you read in the 11th class that on this horizontal line, sine, cos, tan, sec, cosec, got remains same. Means pi minus theta, pi plus theta, 2 pi minus theta, or 2 pi plus theta you are doing, it will remain same, but sign will be changed according to their quadrant. So we are ultimately coming here only after the completion of the two revolution. So the value will remain this one is there. So this is you are getting what? 2 pi by 3, and 2 pi by 3 means 2 into 180 over 3. So that is 120, and 120 is already lying between this one 0 to pi. So therefore the required principal value of cos inverse cos 14 pi by 3 is 2 pi by 3, and this is your answer. Have a look. So now next question is find the value of this one. You have to find the value of this tan inverse 1 plus cos inverse minus 1 by 2 plus sin inverse minus 1 by 2. So in a solution One by one you can take case 1, we can take let x1 is equal to this one, tan inverse 1. So this can be written as tan x1 is equal to 1, that is tan pi by 4. So x1 is equal to pi by 4, which is already belongs to this one, minus pi by 2 to plus pi by 2. The principal value branch is already, we know that. So this is already lying in this one, is that is pi by 4. Now you can solve this. Let, it's your case second, you can let x2 is equal to cos inverse minus 1 by 2. So cos x2 is equal to minus 1 by 2. This is minus cos 1 by 2 means pi by 3. So this minus pi by 3 is here. This does not belongs to principal value branch. This one is there. So this can be written as cos x2 is equal to cos pi minus pi by 3, because the cos is the negative in this here only. In this quadrant is already, you know that there is nothing is there. So this can be written as cos pi minus theta means minus cos theta. So this is equal to cos 2 pi by 3. So therefore x2 is equal to 2 pi by 3, and this is already belongs to 0 to pi. And last is the sine inverse minus 1 by 2. Similarly, you can take this case 3. You can take that x3 is equal to is sine inverse minus 1 by 2. So this is sine x3 is equal to minus 1 by 2. So this is equal to the minus sine 1 by 2, value of sine 630, pi by 6. Or it can be written as sine minus pi by 6. So x3 is equal to minus pi by 6, which is already belongs to minus pi by 2 plus pi by 2. So minus pi by 2 to plus pi by 2. So you know the value of x3, you know the value of x2 and value of x1. And this value you can put here. This is x1, x2 and x3 is already we assumed. So what do we get now? So look at here. Okay, look at here. So now x1 plus x2 plus x3. So what you are getting? x1 is pi by 4 plus x2 2 pi by 3 plus this is minus pi by 6. You can take an LCM is 12, 3 pi plus 3 4 8 pi minus 2 pi. So this is your 9 pi over 12 or 3 pi over 4 as your answer. So have a look. Yes, the same question, there is a shortcut is there, but that property we will discuss in the next video. But here we can apply, because we know then sine inverse x plus cos inverse x is equal to pi by 2. This is the property. Sine inverse x plus cos inverse x is equal to pi by 2. So look at here now. This is what? Sine inverse x plus cos inverse x. That is equal to pi by 2. And this tan inverse 1 is, that is tan inverse into tan pi by 4. So this is your pi by 4. And this is your pi by 2. Solve this one. 4 pi plus 2 pi, this is 3 pi by 4. So this is the shortcut method is there only. But by using this property that we will discuss later on.